I'm going to try to share some thought about mathematics with aim at young people who have not started studying mathematics and who may wonder what's the point? Who cares about mathematics? Well, I'm sure you all heard about the Nobel Prize, which makes the headline of the newspaper. There is no Nobel Prize in mathematics for reasons which are not entirely clear, but every year there are 5 million US dollar of reward in prizes for progress in mathematics. And the largest such prize was funded by tech billionaires. Now, beside this prize, which come every year, now in 2000, the Clay Foundation made a list of 7 famous mathematical problems, and it offers $1 million for the solution of each of them. One has been solved, but still you have the potential to make 6 millions. Now, about these 6 million, I will quote my good friend Noga Allen, who would say there are easier ways to make money, even for 6 million. So why is mathematics cool? Okay, once you start doing it, mathematics is a lot of fun. And specialists in mathematics do get jobs. And I was very glad I got a job, and basically I got paid to enjoy myself doing what I like the most. Now, how can you wish of a better life than that? The need for mathematics is really constantly growing. Even if you don't become a top researcher, there is a need for teacher. You can teach mathematics at high school, it's not a bad job, or you can teach it at university, which is a very good job, in fact. But why do people need mathematicians? Because for a very simple and very important reason, is mathematics is one of our best tools to understand the world. Now let us go to the meaning of mathematics. Geometry. Geometry means measuring the earth. Why do you measure the earth? Because the king owned a lot of land and he wants to know how much he owns and that it's not stolen from him. And you want to know how many cattle he has and count them properly to feel how rich he is. That's how mathematics started. Now, if you don't like arithmetic, let me tell you that don't worry about that. Modern mathematics has nothing to do with arithmetics. I myself have to use my finger to count. Now, the surprise about mathematics is that even though it started by measuring land and counting cattle, it can do a lot more than that. And the first person who really understood it clearly and stated it clearly is Galileo. And he said, mathematics is a language in which the laws of the world are written. So the world looks very chaotic when you look at it, but it is much less chaotic than it looks at first sight, because mathematics explain a lot of it. So let me give you a very simple, very basic example. Now, from ancient time, everybody has noticed that looking at the sky at night, there are the stars which are fixed with respect to each other. And then there are a few planets which move in a complicated way. The easiest planet to see, the planet Mars, which you see very well. And the planet Mars moves with respect to the stars. And it moves in a complicated way. Sometimes it goes east and sometimes it goes west. It looks pretty much random. Now, the ancient people noticed that and they couldn't understand what was the mechanism of it. So they came up with the idea that this randomness in the sky must have to do something with our lives. So maybe we could predict our future by looking at the position of the planet. This is how astrology was born. It was not really a stupid idea when it came up. But later on, then Newton had the greatest flash of genius ever. He understood that the force which makes the apple, legendary apple, fall is the same force that rule the motion of the planet. And after he understood the mechanism, the motion of planet can be computed with fabulous accuracy, explained by rather simple mathematics, in fact. So, conclusion about astrology, the motion of the planet is totally determined. So it cannot have anything to do with the random event in your life. Astrology doesn't make any sense. Sadly, many people still believe in astrology, but if you have a bit of common sense, you will believe in mathematics instead. Now, this great mystery, why are so many laws of the world written in the language of mathematics? And the truth is, nobody knows. This is truly a great mystery of the universe. Now, of course, everybody likes to talk about that. You may like to discuss the topic with your philosophy teacher, but he's unlikely to give you an answer. So to put it another way, are mathematics discovered when you do research in mathematics? Do you discover mathematics in the sense that the theorems are there and you are just the first one to look at them? Or do you create mathematics in the sense that they didn't exist before you created them? Okay, that's a nice topic of discussion among mathematicians. Now, myself, of course, what do I know about philosophy? But I can tell you honestly, since I spent my entire life thinking of mathematics, it's hard for me to believe that they are not somehow part of the universe. Otherwise, I would have lived in a dream, and this is not such a pleasant thing. Now, many people are scared by mathematics. Now you have to understand some sad fact about life is whenever you want to do something which will turn out to be truly fulfilling, it will require effort and dedication. Now, have you ever thought about a concert pianist? A concert pianist is likely to practice 12 hours a day every day. And the top swimmer, he is likely to swim 12 hours a day every day. And that's the way it is. Now, you may enjoy mathematics by doing a little bit less than 12 hours a day, but don't think you will do it in an effortless way. But situation is not so bad because it starts to look difficult, but when you practice, it gets easier. Now, for personal reason, I had some disaster happening with my health when I was 15, and I turned to mathematics as a way to stay alive, and I started doing all the exercise on the textbook we were using. Now, you may think it's overwhelming to do all the exercise, but this is not true. At the end of each chapter, there were 20 exercises, but maybe 2 or 3 ideas. The same idea come over and over again. So when you become proficient, things get very much easier. But you need effort, but effort will bring reward. That's what I'm trying to say. Okay, now there is a problem in your generation which didn't exist into mine, which is many people start to use artificial intelligence tool, which can actually do wonder. This is very scary to me. Please keep in mind the difference between using a tool and relying blindly on the same tool. You need to keep your critical perception, especially as of today, when you ask something to artificial intelligence, you can absolutely not trust the answer to be reliable. So mathematics is a very vast topic. There are many different areas in mathematics. You have number theory. Everybody heard about number theory. You have analysis, you have geometry, you have differential geometry, so many things. Now, you have to think of mathematics as like a sport. People who are good at a sport are not necessarily good at another sport. You never heard of a weightlifter who wins marathon. It's not the same body shape. Now, that means that you may be good at some areas in mathematics and not so good at others. And I know that personally because I was just bad at geometry. And which really, I was fortunate to have my father was a high school teacher, and he could help me with the problem of geometry. So I didn't get discouraged by math overall because of geometry. But this is not my strength. I'm very much better in some other areas. I don't understand why. I'm very much better in some areas than others. And it took me some time to figure out the area where I'm good. And how do you figure out the area you like? That's it. There is another sad truth. There is no other way than exploring. You have to explore the different facets and to see what turns you on and where you feel at ease. And don't expect again to meet instant success. Again, it's like music. You are not going to walk to a piano and play a Chopin ballade like a professional. You will need to suffer and to be persistent. It's very important to be persistent. Now, it's very important and very dangerous too, because you should not be persistent up to obsession. You should be persistent, but you have to know when you are in a blind alley and stop. So being persistent, there are problems I started thinking about when I was 35, and I finished thinking about when I was 70. Now, I didn't think every day between, but I came back to them several times, and each time I made progress. Now, I think the problem is finished, but maybe not. Somebody will come and then do something better. Now, one thing I love about mathematics is success doesn't rely mostly on knowledge and experience. It relies on finding an approach that other people have not done. And it's very hard to explain how this happens. You know, you think about the thing and you think of it, and then the progress happens in your subconscious. Very often, when you think of the problem in the evening and you get stuck, and when you get up in the morning, you realize that you understand a little bit better than you did in the evening. There is some little, like two pieces of the puzzle have clicked together. And once they are clicked together, they stay there. Now the problem, you have made progress. The problem is to find a third piece which clicks. That's why this is why there are many stories in mathematics of relatively newcomers who make big progress because they have a fresh mind. When you are old and you have been studying a topic for a long time, you think you know everything. You cannot get a fresh view. When you are young, of course, you get a fresh view. Now, also, when I say newcomer, you have to be reasonable. Don't think you are going to take the problem I'm going to mention at the end of my talk and solve them by yourself. You have to learn the basics, and you have to study and learn the basics. So the success story I know, okay, they are not magic, but they are very uplifting. I have a good friend whose name is Jin Park. This extraordinary story because she was not a good student at high school, and she became a high school teacher. She didn't become a mathematician. And then she was bored with her life. She went back to university, and then she discovered she had talent. She had great talent. She has solved two major problems in combinatorics. They are published in top journal. Now she's a professor in a top university, and she's going to get honors. She get already one. She's a speaker at the next Math Congress in Philadelphia next summer, which is a great honor, being a speaker in the Math Congress. Now, another thing which I love about mathematics, if you compare, say, with physics or natural science, is that you are much more independent. When you are running a lab, you spend most of your life writing research proposals to get funding for all the equipment you do and the collaborators you need. And math, you don't need that much equipment. You need a computer now. I have a $2,000 computer. It's good enough for everything I need, and to talk to people and communicate with the internet. And Okay, and this is much easier. Of course, you still need a little bit of money to go with conferences, but I would say that I spend a few weeks every 5 years to write research proposal. I didn't spend half of my time like some people do in natural science. So that's a good point. It depends on yourself alone, mostly. Now, you may wonder what it is like to do research. You start with a question, nobody knows how to answer. What strategy do you develop? Now, everybody is different. Now, I talk to people and they don't function the same way. So I can only tell you the thing I tried. The thing is, okay, it's what Descartes explained a long time ago. You cannot start with complicated question. You have to break it into simple pieces. Or if you cannot break it in simple pieces, you have to try to find a related question which will be less complicated and on which is not really what you want to understand, but you feel that it would help you to understand that simple fact. And if it's not simple enough, then iterate. Take the simplest problem which relates to it. It sounds extreme, but one of my successful work has to been about a problem related to physics, which is called spin glasses. And the physicist Giorgio Parisi has invented wonderful structure on objects which are actually mathematical objects. They are purely mathematical objects. He was doing physics on mathematical objects. And these objects are very unsettling for mathematicians. So it was a famous problem, and I'm sure many famous people tried to solve it, but they were not humble enough. I started studying this problem, say, okay, obviously, what do I understand about spin glasses? Let me try to prove, actually mathematically prove, even a very modest statement. And I did that for several years, and then I gained understanding, and then I could nail the real problem. You have to be humble and to understand that you can take only a small step at a time. Okay, another point is, of course, when you try to solve a problem, you have to set out your strategy. You say, I'm going to try to do this and do this and do that, and maybe it will work. Well, if it doesn't work, there are two reasons it cannot work. There may be a technical obstacle, or more likely, so if it's a technical obstacle, you insist. But most likely, it's not a good strategy. So you are stuck in the wrong direction. So don't spend your whole life. It's not going to work. Find another strategy. Now, it's very difficult to find another strategy because you have this road that you have walked and walked and walked at it. And it's hard to see any other turn you could have made. So what I did is simply I dropped the problem and work another problem for 3 months or 3 years, and then I come back to the problem. And when I come back, then I see things in a fresh way, and I say, oh, here I turned left, but what happened if I turn right? Maybe it's more promising. And quite often, I made very big progress in the first few days, because the first few days I tried things I had never tried before. So doing research, it's not impossible job. Once you get organized, you train yourself on simple problems. Don't think you will only solve big problems. That's also important. You get trained at solve problems. So you are never too humble. Try to do easy problems before you do hard ones. And when you can do easy problem just like that, then you do harder ones. Now, another point I want to make is many people who don't know mathematics may think that the goal of mathematics is proving theorems. But the goal of mathematics is not proving theorems. The goal of mathematics is to understand the mathematical universe, because the mathematical universe has so much to say about the universe in which we live. And of course, to prove a theorem, you have to understand how you can build a proof. but the goal is not the proof. So, for example, if artificial intelligence was giving you 100,000-page proof of a big theorem, it would be no use whatsoever, because we know the theorem is true, but we don't understand anything, you see. So, okay, so that's an important thing. And also when you try to understand, I mean, that's the understanding which makes you happy. When you feel you make a jump in your understanding, this is such a great feeling. I had that a few times, and I can tell you these were the most magic time of my entire life. Now, to finish, I want to. Okay, so I mentioned there are these million-dollar problems which have been very carefully chosen by experts, because the reason we cannot solve this problem is we lack some basic understanding in some area which is truly fundamental. So these are the fundamental problems. But there are also problems in mathematics which are very easy to state and very challenging. And if we solve them, I don't believe we will make such a great progress, except we'll be happy to have proven the value of human spirit. And of course, if you solve them, then your name will be famous forever after. So this problem deals with integers, whole numbers, and I'm going to state two such problems. So an integer is a whole number, 1, 2, 3, 4. Now, among them, they are the prime number. The prime number, they are the numbers which can be divided only by themselves and by 1. So the first prime number are 3, 5, 7, 11, 13, 17, 19, 23, and you can find list of very, very many prime numbers. Now, there are infinitely many prime numbers. This is a very nice theorem in mathematics. It's pretty easy. It's proved by Euclid a very, very long time ago, something like 2,300 years ago. So it's a very nice result. Now, you say that two prime numbers form a pair if they differ exactly by 2 units. They cannot differ by 1 unit because the prime number is an odd number. And if you add 1, it's an even number, which is divided by 2. But they can differ from 2 units. Example of pairs, 3 and 5, 5 and 7, 11 and 13. We know many, many pairs, but we don't know if there is a larger such pair or if there are infinitely many pairs. That's called maybe the twin prime number conjecture. Now, another famous problem, which is called the Goldbar conjecture, is even simpler to state. Is it true that every even number bigger than 2 is the sum of 2 prime numbers? Now, the prime numbers are odd, so when you add 2 prime numbers, you get an even number. So if a number is a sum of 2 prime, it is even. But is it true that all even numbers are sum of 2 prime numbers? We don't know. Now, this has been checked with a computer. You can check this extremely far. But even if you check that extremely far and for all numbers, this is a very different statement. Okay? Thank you so much for your attention.